Hello YouTube, welcome back to my channel. So this video marks the beginning of our new series which is called Introduction to Statistics for Machine Learning and Data Science. So we have been going over machine learning series, and I find it like we need to do a bit of statistics before we continue with that series. But I will also be uploading videos for machine learning, so if you're interested in machine learning, you can continue watching the series on machine learning. But if you're new to machine learning and you have started watching that, you might want to watch these two series simultaneously, because the statistics that you're going to cover here will be applied in machine learning and data science series that you have started earlier. So we're going to go over statistics, and first let's begin by defining what statistics is. So statistics is a branch of mathematics that deals with try to make sense of data. This is how I will define statistics, but Wikipedia defines statistics as the study of the collection, analysis, interpretation, and presentation and organization of data. That's what statistics is all about. Try to analyze data, collect data, try to make interpretations, organize data, and try to present the data in using different charts and stuff like that. So that's what statistics is all about. So to become a data scientist, do you have to know statistics? The simple answer is simply just a yes. You have to know statistics because data science is all about statistics. So if you might be asking yourself, why do I have to know statistics in order to do data science? Well, machine learning is all about making predictions, trying to analyze data, trying to make sense of data, regression, and stuff like that. All this utilize statistics methods, right? So data science is all about probability, hypothesis testing, regression, and all of these other concepts, detecting outliers, cleaning your data. All these methods and processes use statistical methods. So this is what you're going to cover, like the basics of statistics, so that you can begin to do data science and actually understand what's going on in the background, rather than just copying and pasting code all over the place. So that's what you're going to be doing. So this course is all about, like as I said, we're going to introduce ourselves to statistics so that we can begin understanding what you're actually doing whenever we do data science and machine learning. So the best way, I believe the best way to learn something is actually by doing it, right? Practice makes perfect, which is many of these tutorials on YouTube, they just have the tutorial part into statistics, right? They just do the pure statistics, like these mathematical channels. They just do go into the statistics. They don't really go into the coding part. So whenever you move from the statistics and you come into Python or any whatever language that you are using, and you try to implement the same stuff, sometimes you get stuck and you have to do a lot of Google search. So whenever I was studying data science, I also had the same problem, and I wish there was a place where they will talk about the theory of statistics and how to actually do the actual coding in Python. So this is what this course is all going to be about, not just the hardcore theory about what is median, what is that, what is a variation, what is a mode, and all of this stuff, what is a standard normal distribution, all of this stuff. And then if you come into machine learning or go into Python, you wonder, how do you code this, how do you implement this, right? So this is not what this course is going to do. So this course, we are going to go into the theory. We will talk about the theory, and then we'll actually do the coding in Python to see how we can apply those theory, the statistic knowledge into code and actually do statistics using Python. In that way, you'll be able to learn Python through this course, and you also be able to understand statistics method, and then you'll be ready for machine learning and data science. So in this course, we're going to cover some of the most used scientific computation libraries in Python, like Numpy, Numeric Python. We also cover Matplotlib for visualizing data, Seaborn also for visualization, Pandas for data manipulation, Jupyter Notebook, which is the editor that I'm actually currently using. It's really powerful. And then also you look at scipy, which is just a very, very wonderful library for statistics and data scientific computation in data science and machine learning that you'll be using. So the language that you'll be using is obviously going to be Python. Why Python? Because Python is very easy to write. Has a lot of support. Documentation on Python is just great. The Python community is just fantastic. Python is easy to read, easy to interpret. It is just like English, right? So the most important point is that Python has most libraries for scientific computation, data analysis, and machine learning than any other language that I know. This is my personal view. like R, Python is way better than R, right? Way better than R, and it's also a general purpose language. So if you learn Python through statistics, you can also do other things with Python, right? For example, you can build dashboards, data analysis dashboards using Python. You can build websites with Python, about data science and stuff like that. So learning Python is just the best way to go for data science, and is the most widely used language for data science. So that's why we'll be using Python. So you have to know Python to be in this course. As I mentioned earlier, no, you don't have to know Python to do this course. We will learn Python as we go along. I will explain to you what variable is, a function is, a method is, as we go along. Okay, so if you have any question about anything that we'll do, leave it in the comment section below. I'll do my best to get back to you. Maybe I'll also make a video to explain that concept to you in Python. So you don't have to know Python to begin this course. You can go learn Python as we go along, but knowing Python will take you a very long way, take you very far. So if you have a bit of knowledge of Python, it's really good. So you can just go to Google and then just read the very few introduction to Python pages, like the first 5 or 10 pages will take you a long way. Okay, so if you don't know Python, we'll learn as we go along. So we need to install the things that we need. So if you already have Anaconda installed on your computer, feel free to skip this video and go to the next video where we'll go into the theory about statistics, and then we'll begin to do some coding. So if you already have Anaconda installed, you can just skip this. If you don't know what Anaconda is, you can just go to Google and search, and then you can install Anaconda for Windows, Mac or Linux. But for starters, right, I believe some people here are just starting out with Python, so Anaconda installation can be really tricky. So we just use a normal Python virtual environment to keep things simple. So if you're on Windows, right, I don't have a Windows machine, and the process of doing creating a virtual machine in Windows is something that I'm not really familiar with. So I am going to leave this link here. It's just a YouTube video that will take you through how to install Python for Windows, how to create a virtual environment for Windows. So once you have done watching that video, you can come back to this video, and then we'll install the library that you'll be using during this course. Okay, so go back there to this YouTube link. I'll leave it in the description. Watch this video if you are using Windows on how to install Python and how to create a virtual environment in Python. So if you are wondering, you come to bring you to this page, with the official page for Python. So here you can simply just click on downloads, and then you can select downloads, and then you can select the operating system that you're using, and then from there you can download it. If you're using Windows, it will download it, and then you just click the executable file, the installer. Make sure that you include Python within your general path. Again, follow this tutorial. It's really just great. Please follow this tutorial so that you don't have any issues along the way. So once you're done watching that tutorial, and I believe by now you already have Python installed and you know how to create a virtual environment. So let's go ahead and actually see how we can create a virtual environment for those of us who are on a Linux machine. Okay, so to do this, first of all, we need to create a virtual environment. So I'll open up my terminal right here. So if you're on Windows, follow along from this step onwards. Okay, so we need to make a directory. This directory is where we're going to be keeping all our project files. Okay, so we just call it statistics. I'm going to call it statistics. Feel free to call it anything you want. So if you're on Windows, Mac or Linux, this command is going to work for you, and it's just create for you a folder. Okay, so I've changed the directory, and now going to statistics. Okay, so I have now created a folder on my desktop in a folder called content, and I've created another folder in there called statistics. So if you're on Windows, you might want to do a change directory, and then you need to say desktop, and then from after you run this command, and then you follow up with these two other commands so that you can create a folder on your desktop. Okay, so I hope you are familiar with the Windows environment. So once that you have done this, we have created a virtual environment. We have created a folder we're going to store in our project files. Now let's go ahead and actually create a virtual environment. So for Windows users, by now you know how to create a virtual environment on Windows, right? So you just copy the command for creating a virtual environment, and you paste it in your terminal, and then you press enter. This will create for a virtual environment within this folder called statistics. So if you're on a Mac or Linux, you have to say Python 3 and then -m venv, and then you can follow it with the name of the virtual environment you want. I will call mine venv. Feel free to call it anything you want, okay, but just remember that name. So this will go and actually create for us that virtual environment. So once it's done, we'll have a virtual environment. Okay, so this command will not work for Windows users. So Windows users, as I said, refer to that video, and I hope by now you know how to create a virtual environment. So just copy the code for creating the virtual environment, paste it in here, press enter, and it will create for a virtual environment within this this folder called statistics. So now that you have created a virtual environment, I can do an ls, and you can see we have a folder in there called venv, which is the name that you have given our virtual environment. So if you're on Windows, to check this, you can also do a dir, so just do a dir and it will also work for you. Okay, so now that you have created a virtual environment, you need to activate the virtual environment. Again, Windows users, this command won't work for you, so I hope by now you know how to activate a virtual environment by watching that video. Okay, so you activate your virtual environment. This works for Linux users and Mac users. So you activate your virtual environment, and whenever you activate your virtual environment, you can notice the name of the virtual environment, in parentheses in front of the line. So that shows that your virtual environment is activated. So I'll just clear my screen. If you're on Windows, I think it's called CLS, so this will clear your screen. So once you have the screen cleared up, you can go ahead and actually start installing the library. So let's go back to our presentation and then we copy this code. Okay, so we're going to install this specific library. So I'll copy from here, from the pip one. I'll copy all of this, and then I'll simply copy this code, and I'll move back to my terminal, and I'll do Ctrl Shift and V to paste it. Okay, so I'm using pip3. So if you're on, you know which pip version you're using. If you're on Windows, I think pip will just work for you. If you're on Linux, if you're using Python 3, you have to say pip3. If you're on Linux, I think it's if you're on Mac, I think it's also the same thing, right? So we also need to install another library called Seaborn. So we're going to this pip3 install is just, pip stands for a packet, it's just a packet manager in Python, right? So it's going to install, you're telling this package manager to install for you Numpy, scipy, Matplotlib, IPython, this stands for interactive Python, Jyputer notebook, Jyputer, and then which is we're going to get Jyputer notebook, Pandas, and then the Seaborn, which is the library that we have discussed, that you're going to cover in this course. Okay, so at this point, you just go ahead and actually press enter. This will go ahead and actually install for you. So this will take some time depending on your internet speed and also the processor speed. So as you can see, it's collecting the libraries and it's going to install this for me, so it's going to take some time. So you just have to wait, and when this is done, I'll resume the video, and then we can continue from there. Yeah guys, I'm back here, and you can see that my installation has been completed and all the libraries have been installed on my computer successfully. So I'll go ahead and actually clear the screen. So we have all these libraries installed, so we can go ahead and actually activate start our Jyputer editor, which will be the editor that we'll be using for coding. So to activate, you just have to be make sure your virtual environment is activated, and then you just have to type in Jyputer and then space notebook. Okay, so this will open up Jyputer notebook, and it will start a server on your local machine, and then it will open up a certain URL. So it will open up this URL in the browser. So you can just copy this and paste it, or by default it will open it automatically. So you just have to wait for it to open, and you can see it has opened that URL here, right here. So in there we can see we have only one folder within our statistics folder. So is this every folder within the statistics folder, right? Every folder within the statistics folder will show up in the in here. Okay, so in the statistics folder we have the virtual environment folder. That's why it shows up here. So anything you put in that folder will show up here whenever you start the Jyputer notebook. So let's go ahead and actually create a Python notebook, and then we can see we can just do a simple hello world in Python, and we can conclude it for this video. So I'll go ahead and actually name it, and I'll call it intro, just like that. Sorry, this is a typo. So this is a intro, there's a T there. So yeah, so from there we can go ahead and actually write a simple hello world program in Python. So to do a hello world in Python, you just have to say print parentheses double quotes, and inside of the double quotes you put in hello world, or whatever you want to print out on the screen, hello world, and then you can press shift and enter on your keyboard to run the code, or you can just press run here. So make sure you select the cell. So to select the cell, you just press on that cell, and show the green shows that it's selected, and then you can run it, and you can see we get hello world. So that's how you can print a hello world in Python. Okay, so this could be a double quote or a single quote. Python doesn't mind. So but if you use double quotes, make sure you use double quotes on both ends. If you use single quotes, make sure you use single quotes on both ends. So this is how you can simply create a simple hello world in Python. So what you have done now, you have installed the libraries, and you are ready to start coding and get started doing statistics using Python, right, and begin our journey for data science. So we have covered all this, and you have managed to install all of the libraries that we need. So in the next tutorial, we'll look at the terminologies that are used in statistics, and then from there we'll begin to code in Python and doing statistics using Python. So So this is the second tutorial in our Introduction to Statistics for Machine Learning series. So in this tutorial, we're going to just go over the terminologies that are used in this course and the terminologies that will be used through this course, and just get ourselves familiar with the statistical terms that we'll be using. So in data science and machine learning. So we've already discussed what statistics is, and again, statistics is just a branch of mathematics that deals with like making sense of data, right? This is how Wikipedia defines statistics as a collection, analysis, interpretation, presentation, and organization of data, right? To make sense out of data. So let's look at the two branches. There are two main branches of statistics. That is the descriptive statistics and then inferential statistics. So descriptive statistics is just a branch of statistics that deals with trying to summarize data, right? So trying to describe data trying to summarize data with an effort to describe data. It utilizes mean, median, variability, and so on. If you don't know these terms, don't worry, we'll probably look at these terms in the future tutorials, right? So in the next tutorial, we'll probably look at mean and other stuff. So what this means, for example, if I tell you the average age of my friends, right? The average age of my friends, you can probably have an idea of the kind of people I hang around with, and you can also like try to predict, right, what you might probably be doing, right? Because maybe we are teenagers, and there are certain things that people of a certain age group do, right? So that you can how we can describe a certain group of population just by using a single figure. So that's what descriptive statistics tries to do. So it tries to describe population data set just by using a single or a collection of values, right? Like median, their average, their mean, and so on. So this is what descriptive statistics is all about. So inferential statistics is the other branch of that deals with trying to make conclusions, data-driven conclusions, right? Try to make inferences from data. So let's try out. Let's look at what our main focus is going to be for this course. So we're mainly going to focus on. Let me go back here. We are simply going to focus on descriptive statistics for now, and then later on maybe we might move to inferential statistics. So our main focus for now will just be descriptive statistics, right? That's what we'll be using most of the time. So let's look at what data is. So data is just any raw figure input fact that makes no sense on its own, but whenever it's processed, we can draw insight and information out of it. So whenever you have a random collection of input, for example, if I give you a random number of numbers, right, you might ask me what are these numbers for. But if I tell you this number are the ages of the people that I know, right, that gives the data a context, and if you find, you can process that data to get information. You can find the mean of the ages, and then you can do a lot of different things with that data, and then you can find the average age of my friends or stuff like that. So that is what data is on its own. It makes no meaning, but when processed and given a context, it becomes information and very useful, right? So that let's look at the taxonomy of data types. So taxonomy is just the science of naming stuff. So taxonomy is the science of taxonomy of a data type, which is like naming the data types. So we have two major data types. We have numeric data types and we have categorical data types. So numeric data types, these are data types which we can find on the number line. So any number any data that you can find on the number line is known as a numeric data. A 1, a 0, decimal, 4.6/7 fractions, decimal, all of these numeric values are called numeric data. So numeric data can be divided into two different classes, right? So there's continuous data and then there's discrete data. So continuous data is just a data that can take any value between two ranges. So if you have a number between, for example, an age, the height of a person can take any value between maybe 4 feet to maybe 7 feet, right? So that's a continuous data. You can take any value within that range. So a decimal, a person will be 5.5 feet, 6.6, and stuff like that. So that is continuous data. It's usually called it's usually a measured data. So it's usually decimals and fractions. So we also have discrete data. So discrete data is the data that can take on a discrete value, and a discrete value could be a 1, a 2, a 3, or something. It doesn't include decimals, right? And doesn't include fractions. It includes all integers and the whole number. So I made a typo here. These are integers, right? So there's no n over there. So sorry for the typo. So also let's look at categorical data. So categorical data, this is just names of places, cities, fruits, gender, and stuff like that. For example, Dar es Salaam, Nairobi, Helen, Thomas, California, male and female, all of these are known as categorical data. So when we have a data set where you have a male and female, then that is known as a categorical data set. We have a data set containing cities, name of cities, then that comes a categorical data set. Okay, so there are two types of categorical data. So there is a nominal data, which is a form of categorical data whereby there is no ordering between the different categories. For example, if you have a data set in which there are male and female, right? So we don't want to say that male is above female or female is above male. They are just variables. They are just gender, right? So that nominal. There's no ordering or hierarchy between the two categories. Now, this might not be making sense at this point, but whenever we go into machine learning, we proceed into this tutorial, and then there's also something known as label encoding, and then there is one hot encoding. This is where this becomes really powerful. So if you don't understand it for now, don't worry about it. In the future videos we'll talk about it, and then you can refer back to this and it will make complete sense to you. So let's look at ordinal data. So ordinal data is a type of data in which there is an ordering, a hierarchy between the different classes. For example, if I say very satisfied, least satisfied, and not satisfied, you can probably give this value, right? Maybe you can say satisfied, you give it a value of 3 or a weight of 3, less satisfied, you give it a weight of 2, and then not satisfied, you give it a weight of 1. So very satisfied is above less satisfied, and less satisfied is above not satisfied, right? That is ordering. There's an ordering that is known as an ordinal data, and it's a form of a categorical data. So let's go to taxonomy of variables. So there are two main classes of variables. The variables could be independent variables and dependent variables. So independent variables are also called the predictor variables, and dependent variables are also called the target variables, right? So whenever I have maybe a height and an age, let's say that with the assumption that age determines the height, right? So then age will become an independent variable, and then height will become dependent, because height is dependent on the age of an individual, and the age of an individual will determine his height, right? So height becomes a dependent variable, depends on the age, and age becomes independent variable because it does not depend on height, right? So in this case we have y equals to mx plus c, the linear equation. So you can see that this will be the dependent variable because its value depends on what the slope is, what m is, what the independent variable x is, and what also the constant is. So in this case, x will become the independent variable or the predictor variable, and then y will be the dependent variable because its value depends on the value of x, right? So x will be the independent variable. These two will be constant, so x will be, this value will depend on the value of x, right? So x will be the independent variable and y will be the dependent variable. These other values are constants, right? The slope is constant and also the intercept is constant. So there we can also further divide this into qualitative and quantitative data. So qualitative data variables, qualitative variables just hold the quality of things, and then quantitative holds the quantity of something, right? Numbers, right? So now that you have looked at that, let's look at what a rectangular data is. So a rectangular data is just a two-dimensional matrix consisting of rows and columns, just like a spreadsheet in your normal Excel or whatever, LibreOffice, whatever you're using. This is just a normal spreadsheet form of data. So it's just a data in a tabular form consisting of rows and columns. So in data science, we call a rectangular data a data frame. We call it a data frame, and we'll look at this when we go into Pandas. And if you want to take a look at Pandas, I have a whole series on Pandas. You can click on that tutorial and watch the whole series on Pandas, and there the very first tutorial we talked about what a data frame is. So we also have features are the columns within our data frame. It's also called an attribute, a variable, or a predictor. A row is just a column of that data frame, a column of that spreadsheet, a column of that table that consists of different columns. So features. So we can also call it a case, an instance, an example, or a sample. So non-rectangular data consists of spatial data and time series data. This forms non-rectangular data. So let's talk about data sampling. So a population in data sampling is just, we have two main things. Let's talk about population and then a sample. So a population is the entire group that you are interested in whenever you're conducting a research. Okay, so I want to connect a research about maybe the lions in a zoo or the lions in a game reserve. So all the lions in the game reserve are the population. So I'll collect information about all the lions, maybe their weight, and then I'll write that down by doing a survey. And then I want to, maybe the data is just too much. Maybe I got 1 million weights of lions, right? So I can't really process all that data. So I just want a sample. So I'll pick some values, right? Maybe I'll pick 500 weights. Just from that 1 million, I'll pick up 500. That will become my sample. So a sample is a subset of the population. So we process the sample, we analyze the sample, and we can get information from the sample. So N, or capital N or small n, is the size of the sample or population. So that's what the symbols that we use for representing the size of a sample or a population. So data sampling techniques. So I talked about how we can pick data, right? How we can pick different weights of a lion. So how do we do this? There are different techniques that we can do this. So the first one is called the random sampling. So the random sampling, we just randomly pick values that it says. So we just randomly pick the weights of lions. We don't do any kind of discrimination. We just randomly pick values. That's what is called random sampling. And after we do that, we have random sample. It is the result. The sample that we get from random sampling is called a simple random sample. Okay, and then we have a stratified sampling. So stratified, what we do in stratified sampling is that we divide the data into stratas or classes. So for example, I'll divide the weights of the lions into females and then males, right? So we have female lions and then male lions, their weights, right? I'll divide it into two parts, and then I'll do a simple random picking from each of those. So from the male class, I'll randomly pick some values, and then from the female class, I'll randomly pick some values and then put it together, and I'll have a sample. So that is called stratified sampling. So let's move on to bias. So what a bias is. So this, we're just covering the basic terms, so just to get you familiar with the basic terms, so that whenever you go into the coding and further in the videos, you don't get confused as to what terminologies are when you use them. So we talk about systematic error in statistics. Is called a bias. So whenever we have an error, it's called a bias in statistics. So this brings us to the end of this tutorial, right? So in the next tutorial, we'll look at the measures of central tendency, we'll look at mean and stuff like that. So guys, thanks for watching. If you find this tutorial helpful, please don't forget to give this video a thumbs up, subscribe to this channel, hit the notification bell to see updates for more videos. Well, again, if you would like this tutorial, give it a thumbs up. If you hate the tutorial, give it a thumbs down, and then in the comment section, let us know why you hate this video or why you like this video. And if any feedback on how I can improve on these tutorials to help you guys, leave a comment in the comment section below, so that I can know what I'm doing wrong and what I'm doing right, so that we can improve and all of us benefit from this channel. So thanks guys for watching. Again, please kindly subscribe to this channel. It is one of the ways you can probably help my channel. Please subscribe. Thanks for watching. Keep safe. See you in the next tutorial. So in this tutorial, we're going to look at measures of central tendency. We'll look at the theory of mean, and then we'll begin to code. Okay, so central tendency helps you to find the middle, the average of a given data set, right? This measures the indicates the values in the distribution fall under. What values the distribution measures indicates the most values in the distribution, and what these values fall under. It also refers to as central location of the distribution. So whenever we're talking about central tendency, we're basically talking about three most commonly used parts. So measurement. So there's a mean, there's a median, and then there's a mode. So in this tutorial, we'll cover mean, and then the next we'll cover median and mode. So we'll cover mean in this tutorial. So what mean is? Mean is also commonly known as the arithmetic mean, or some people on the street can be called average, right? So it's just the same thing. So to find an average, you find the sum of all the values divided by the total number of values. So for example, if you want to find the average of this value, we simply add all up these values, and then we divide it by the total number of values in here. So we'll add 1 to 3, 5 plus 7 plus 3 plus 2 all the way to 23, and then we divide it by the total numbers within this data set, which is 1 2 3 4 5 6 7 8 9. So we divide that value by 9. So we divide the sum of all these values by 9, and that's how we get mean. So mean is commonly denoted by x bar. So x, and then there's a bar on top of it, that is called x bar. So there are two types of mean, the symbols for mean. They can be sample mean, which is just calculated from the sample, denoted by x bar. And then there is the population mean, which is denoted the mean for the whole population, denoted by the Greek letter mu, which is just this. Okay, so now let's try to see how we can calculate a mean in Python, right? To use Python libraries to calculate mean. So I'll just open up my terminal, navigate to where your virtual environment is, the statistics folder, and make sure you have your virtual environment activated. You can see mine is activated here. Okay, so if you don't know how to activate, you can watch the right video, the last tutorial, the first tutorial, and then if you're using Windows, you can refer that video which I suggested to you guys. Okay, so now that I'll just go ahead and actually open Jupyter. So now I'll just go open Jupyter Notebook like this, and then I'll press enter. This will go and actually open Jupyter Notebook for us. So let's wait for it to open up. It will open up at localhost, and then this port 889. Okay, so in the last row we created this, right? So let's just go ahead and actually create a new one. We'll call it main. So create a new IPython notebook. So we'll call it we're just going to call it main. So I'm just going to call it main, and then we save that. So we're going to import two libraries. We're going to one library other. We're going to import just Numpy. So we're just going to import Numpy as np. So in Python, this Numpy library is a library that is written by other people and provides us a lot of functionality. In the first row, we learn how to install it. So now we just bring it into our application to use it. So we're telling Python, hey, bring in this library, we want to use it. So we're importing Numpy as np. So we're importing it as np, so you don't have to type Numpy all the time. So you just have to type in this code. So now we have that library imported. This is what we call, this is how we import libraries in Python. So now that you have imported library, you can say np dot, let's call it data, and then we say np dot range. Let's call it a range. It's called a range. So this is just a method, the method that comes with pandas that will generate random values between a certain range. So we want to generate numbers starting from 20 to 200, right? And then we want what is the step that we want. So we want to say, let's say we want what is the step, maybe to generate 20, and then how many steps should this keep? Maybe we should generate 20 and then 25 and then 30, like that. So we have to specify the steps, right? So I'll just leave the steps to be 20. Okay, so have the 20 between our data. The steps will be 20. So I run this code. Just press shift and enter on your keyboard, or you can simply select the cell just by clicking on the cell and then pressing the run button. So again, here we can do data, and then we can run the cell. So you can see we have this data set, which is just called an array, a Numpy array. Okay, so in Python we have also something known as a list. So it's a list, and then you can just do this, and then in here you can store data. We can just do 2, 3, 4, 5, 6, just like this. So and then we can do a list. I call it a list, and then run this, and then we can see we have a list in Python. Now these are two different things. A Numpy array is much faster than a Python list, because a Numpy array is written in C, and C is faster than Python. So that's why I'm using a Numpy array for faster computation. So if you want, most of the time what you'll be doing as a data scientist, you'll be working a huge amount of data, you want that speed, so always use a Numpy array rather than a Python list, because Python list computation is very expensive, because Python lists are actually objects, right? Okay, so now that you have done that, I can just do data dot main, just like this, and then I can run this cell. So it's going to return to me the mean of these values, right? The average of these values. That's how you can find the average of these values. So all these values, if you add them up divided by the length of this value, you can get 100. So let me just do it again. Do data dot sum. Sum return to us. Let's just store it in here. Call it sum, and then we'll store it in here. So we are going to get the sum, and then we can print out the sum. So this return to us the sum of this value. So and now let's look at the length of data. So we look at the length of data, and the length of the data, just say length. This stands for length, and then you pass in the data frame, the data array that you created. You pass in here. It returns to how many elements are inside of here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 elements within that thing. So to get that, you just pass in length, and then to get the sum, you just do the data frame dot sum. It returns to you the sum. So now if you take the sum divided by let me just call this length like this, and then yeah, run this cell. So I'll pass in here, and I'll pass in length like this, and then I run it. You can see we got 100. So we got the same value as before. So we just found the sum divided by the length of data, so we get the mean. So to do it in a shorter way, we just have to say df dot mean, just like this, and then you get the mean of the data. So that's all we do to calculate the mean in Python. So that's how we can calculate the mean in Python. So let's continue with our tutorial, and then let's look at other variations of mean there is. So we have variations of mean. So that we have the weighted mean. So weighted mean is the sum of the product of the values multiplied the corresponding weights divided by the weights, the sum of the weights. So that's how the formula is. Okay, so there is a line here. This is a fraction. When I go into presentation mode, it doesn't show it, but whenever I quit the presentation mode, you can see we have that line there. So we take the weights times the values of the in the data set divided by the weights of that data set. So let me just show you what I mean by that. It might be a bit tricky to understand. So let's take an example of a school system, right? So in a school, maybe you have a test, a quiz, final exam, and homeworks. All these might have weights, right? Maybe the final exam has more weights than the test and the quizzes. So these are the categories, these are the weights, and this is what the students score. Let's take one student. So the test weights 20%. So we take this times 20%, we put it in a list, we write it down, and then we take the quiz, we take 50, which has a weight of 15. So we take 15 times 80, write the value down, and then we take 40 times this, write the value down, 25 times this, write the value down. So we add up all the values we get from multiplying this, all of these corresponding elements, right? So after we have that value, we need to now to divide it by the sum of the weights. So this plus this plus this plus this, we divide it by the sum of the products of these corresponding elements. That's how you calculate weighted mean. Okay, so this, you can see this will be over 100, right? So now let's see how we can calculate weighted mean in Pandas. So let's generate let's call it score, generate a random numbers, which we just call np.arrange. Let's say the students score numbers grades. Let's just let's create a normal array, so we can learn a new method. So we can call it array. So this another way we can create an array in Numpy. So anyway, we need to pass in a Python list. We've already discussed list just a few minutes ago. So let's say the student got let's just copy these values in here. So the student got 20, 15, oh sorry, 75, 80, 98. So 75, wait, 78. Okay, so 78, 80, 98, and what else? 98 and 98 and 89. So 89. So 89. So these are the scores of the student. Now let's calculate the weights. So you need weights, and then in here you need to pass in weights. We need to create another Numpy array. So go to numpy.array, and then you need to pass in a Python list. So let's look at the weights of these marks. So the weights are 20, 15, 40. 20, 15, 40, and 25, I believe. So 20, 15, so 20, 15, 40, 25, right? So these are the ways. So just run this, and then we have that there. So now let's go and actually calculate the weighted mean. So you can just do np.average, right? To calculate the weighted mean in using Numpy, we say average. It's a bit confusing because mean and average in the kind of normal on the streets kind of mean the same, but in here they're different. So you just press shift and tab on your keyboard, and then you can see the documentation. So you need to pass in an array of the scores, and then you also need to pass in weights. Okay, so there's also something known as axis. We won't talk about axis for now. So we just pass in the score of the students, and then followed by the weight. So you need to pass in score, and then you need to say that weights. Let me just is this weights. So yeah, weights. Run the cell, so you can find that they have the weighted average of the weighted mean of the student is actually an 88.5. so that's roughly about 89. So if you calculate the actual mean of the student and the weighted mean, there's a difference, right? So that's a variation of the mean. Okay, and then also have something known as the trimmed mean. So if you have a trimmed mean, for example, let's say, let me just bring you back here. We have this array, right? These numbers, right? Let's just go back up here. Let's use this one because it's much detail. Let's say we have these numbers, and then you have to calculate a trimmed mean. And then what trimmed mean does is that you remove some numbers from both ends, some values from both ends. So we want to calculate the mean, the trimmed mean, by removing two values from both ends. So what you do is that you remove two values from this end, and then you remove two values from this end. The remaining result, you find the mean of it. Okay, so let me just show you what I mean by that. So you can just say data. Let's just print the data here, so you can have it here. So I want to remove the 20 from 2 from this side and 2 values from this side, and then I'll find the mean of the remaining. That will be our trimmed mean. So I just go data equals to data, and I want to move from this. We start in Python, we start counting from 0 based indexing. So this will be 0, this will be 1, this will be 2 and 3. So we start from 0. So this is 1, 2. So we want to start from 3. So in here we'll put in 3, and then 3, 2, and then we want to remove the last, so we just have to say the length of this minus 2, right? So we want to say this is 1 2 we start from, so 1 2 3 4 5 to 5. Then we run that and you can do data, and you can see we have only 2 values. So why this happened is that we need to start from 2, right? My bad. So this is actually 0 1 2, right? Starting from 2, and then we're going until 2. This is 0 1 2 3 4 5 6, right? 6. So we put in here 7 because the last number is ignored, so we put in here 7. Sorry, this is 7, and then we can run the cell. So we have an empty array, so I don't know why we're having that. So let me just check this out. Let me go 6, and then do data. I'm still getting an error, so let me just try to run all of this. Let me just try to run the whole cell again. Yeah, we have that values there. Sometimes Numpy really gives back me this, so just put in a 7, and then I need to run all of this again. So run all of this. Yeah, we have that value. So we have 60 80 100 120 and 40, right? After removing 2 values from both ends and removing 2 values from both ends, so we have these values, and now we want to find the mean of this value. So if you find the mean of this value, that will be the trimmed mean of the data set dot mean. So now this is how trimmed mean is all about, and we go to 100. So let me just run all of this cell again. Sometimes I don't know if that's the actual mean. Yeah, so maybe this is the actual mean, so I can't really tell. The best thing sometimes to do is just to give it a different name so that you can avoid that kind of conflict sometimes. So I hope that we didn't the Numpy really understood. I mean, we didn't make any errors, and the actual value for this is 100. So you can just actually type this into your calculator just to confirm. So this will be 60 plus 80 plus 100 plus 120 and then plus 140. So you run this, and then you divide it by how many elements are in there. So 1 2 3 4 5, then you divide it by 5, and then the answer is 100. So the trimmed mean of this value after removing 2 values from both ends is actually 100, and Numpy is correct. So we are correct on that. So that's how trimmed mean works in how we can calculate trimmed mean. Okay, so the first thing that we're going to do first is that we actually scale the first thing we do is that we need to have the data sorted. So you can come back here, you can see that our data was actually sorted, and then after sorting our data, we can drop the values from equal values from both ends, and we drop 2 values from both ends, then we calculate the mean as we normally did. So this is how we can calculate trimmed mean in Pandas, using Pandas. So this is the formula for trimmed mean. So again, there is a line here, so let me just exit the presentation mode so you guys can see that line. So it's just this is the formula for trimmed mean, and this the values to remove from both ends. So this is a formula, so you can actually write a program to calculate that for you. This is very complex. I saw this online, and it's really a bit complex, so I didn't want us to dive into complicated stuff right now because some of us are still new to Python, right? So yeah, that's all I wanted us to discuss in this tutorial. So in the next tutorial, we'll probably look at median, and then look at median and mode, right? And then we go into variance and standard deviation and stuff like that. So thanks for watching. If you find it helpful, again, please kindly like this video, subscribe to this channel, hit the notification bell for more videos like this. Thanks for watching. Keep safe. Please don't forget to like this video, and if you like this video, drop a comment in the comment section why you like this video. If you hate this video, give it a thumbs down and leave a comment in the comment section to why you hate the video, and give any feedback on what I'm doing wrong and how I can improve on this set of series that you're doing. Thank you guys very much. Please kindly hit the subscribe button and give this video a thumbs up. Thanks for watching. Keep safe. Today's tutorial, we're going to look at the measures of central tendency, and we're going to look at median. So in the last tutorial, we looked at mean. In this tutorial, we're going to look at median and mode, and then we'll be done on the 3 basic measures of central tendency. So you're going to look at first start with median. So median is the middle value of a given data set. Whenever I have a data set, you first arrange the data set in an order using order statistics. You either arrange it in ascending order or descending order. So after arranging it in any order, whether ascending or descending, you find the value that the value at the rank that divides the data set into 2 different equal parts. So that's what median is all about. Median is also called the 50th percentile, and in the future videos we'll look at percentile, and the reason why it's called the 50th percentile will all make sense to you. So Now let's go look ahead and see how we can calculate a median using Numpy. But first, let's look at an example of a median. So for example, I have this set of numbers 5, 6, 7, 8, and 9. You can see these numbers are ordered, right? So now, what is the median of these values? The median is a value that divides this data set into two equal halves. So you can see on this side we have two values, and this side we have two values. So the number at the middle is called the median. That's what the median is. It divides the data set into two equal halves. We have two on the left and then two on the right. And so this in the middle, the value is called the median value, the median of a data set. So let's look at another example. What if you have two values at the middle position? For example, here we have this value here. Let's say we divide this is two values. This is 3 on this side, and this is 3 on this 2 on this side, right? So we have 2 on this side, 2 on this side, right? We have 2 on this side, and then we have 2 on this side. So there are two numbers in the middle that divide this value, right? So that is 7 and 8, right? So how do you find the median in this case? So in this case, what you simply do is that you find the average of 7 and 8. So we add 7 and 8 together. That will give us 15, and then 15 divided by 2, that will make it to be 7.5. So if there are whatever numbers that make up the find the middle, we just sum them up, and then you divide by the total number. So you basically just find the mean of it. So if you don't know what mean is, you can go and watch the last tutorial where we discussed what mean was. So that's how you can find a median in using the manual way. Now let's see how we can do this using Numpy. So I'll go ahead and actually create a new notebook, and I'll call it median in mode. I'll just call it median. Median. This is median, and median underscore mode. Just call it like that. So in here, we're going to import the libraries that we're going to use. We're going to import Numpy as NP, right? We're importing Numpy as NP, as NP, and then you're also going to we all need Numpy for this. So create data, and then this will be just be Numpy dot arrange. I want to create a range of values. So I want to create values starting from maybe I start creating values starting from 20 to 200. I want a step of 20, right? Just like we did in the last tutorial. So I'm going to do data, and then I can print that. We have this data set right here. So it consists of 9 values. So 9 values. So there will be we can divide it into 4 on one side and 4 on the other side. So whenever we have an odd number, you just get one middle value, right? Because of, for example, 9, we have 4 on one side and 4 on one side. That to be 8, and then the middle value will be the one that makes it 9. So if you have an odd number, you can just get one value for the median as the middle value. If you have an even number, like for example 4, then the middle value will be 2. So you need to define the average of these two middle values. Okay, so you can just do data dot median, and then run that. So this will return to us I got an error. Is why I can find the median. So okay, so let me just do numpy dot median, and then in here passing data, and then run this. So you have the median right here. So the median is 100. So let's try to do this. So 1, 2, 3, 4. Let's first look at the size of this. So we just do the length, and then we passing the data. This will check the length. So we have 9 values there. So we should have 4 on one side and 4 on one side, and then have 1 in the middle. So 1, 2, 3, 4, right? 1, 2, 3, 4. So we have 100 there. So we have the middle value as 100. That's perfectly right. So let's do another one, call it x, and then do np dot arrange. We want to start from 10 to maybe 25 steps of 3. So we can do x, and then we have that value. So we cannot, let's do the length of x to see how many values we have. We have 5, right? This is an let's try to create an even number. So let's make it 20. Let's make it 29. See, yeah, we have 7, which is also an odd number. Let's make it 28. Yeah, we have 6, which is an even number. Now we have an even number. We have 2 on this side and 2 on this side. So the median will be the average of these two, right? So we can just do np dot median, and then we can do passing x. So run that. So and then we have 17.5, which is the 16 plus we can just do it here 16 plus, sorry, this is actually 16, so this will be 16 16 plus 19, which is 19, and then we want the answer by put this in parentheses, and then we divide it by 2, and we run that, we get back 7.9. So that's how we get the median of that data set. So that's how you can calculate median using that formula. Okay, so now that we have done that, let's go ahead and actually start going over the mode. So now you have looked at median, and it's just the middle value. Okay, so let's move on to here. So we can go over the mode. So the mode is the number with the highest count, the number with the highest frequency in the data set, within the data set. So for example, I have this data set of numbers right here, right? So what is the mode in this data set? So the mode is 1, because 1 is the most frequently occurring number. So let's prove this. Let's see how we can do this in Numpy. So we just call it np, let's call it y, which is just be np dot let's create array. And then you need to pass in a Python list. So let's pass in a list, and I'll paste in the numbers that I have copied from there. So now that we have that y value within a NumPy array, let's go and add and actually import one more library. So let's scroll up here, and then up here we in Python we usually import our libraries on the very first line. So you can import it anywhere in the code, but it's just like best practice to put it up so that you can always refer to the libraries that you are using. So we're going to import let's say from scipy. Remember we saw the library called scipy, import stats. So we're going to import that. So now we move up down here, and then we just say stats dot mode, and then we pass in y. So run this cell, and then we can see the mode is actually mode array is actually just 1. So we have 1 there, and that is the mode of the data. So let's try to make 3. Let's include a bunch of 3s in here. So we move up here, and then we make it 3 3 3 3 3 3 3 3 3 3. Yeah, we run that, and then we can see the mode now is 3, because 3 is the most frequently occurring number. So that's how you can find mode and median using number in Python. Okay, using a NumPy and scipy. Okay, so what is the best measure? We have looked at the 3 most common central tendencies measures, right? So now let's look when to use mean, when to use mode, and when to use median. So whenever we have a normal distribution, right, we'll talk about normal distribution in the future, but if we have a normal distribution like this bell curve data distribution, the mode, the median, and the mean, the median and the mode are all equal. Okay, whenever I have a normal distribution, which we'll talk about in the future tutorials, then you can use any of the 3 because they'll be equal. Whenever I have a skewed data that is not normally distributed, you have the best thing to do is not to include the best thing to do is actually to use the mean, the median of the data. Okay, because median is robust, and it is what I mean by robust in statistics, that it is not sensitive to extreme values. When you have a skewed data, there's some data that may be way off, right, just extreme values. So this median, if you use mean is very sensitive to these values. So mean is not robust, but median is robust, and for this reason median can be used for skewed data. Okay, so you can also use mode for this, because mode the value won't affect mode. For example, I have this data set here 1 2 3 4 and 5, right, and then I change 5 to become sorry, these are actually commas, right? Just change this right here, sorry for that. Change this, it should be commas and not decimal points. So run that. So we can see we have this data set here 1 2 3 4 5, right? So 1 2 3 4 5, and then I have written the same data set, and I've only replaced 5 with 30. Okay, now tell me the mean or the median here. The median is just 3, right? The middle value, we did 3, right? Now even if I change 5 to become 30, which is way off, right, but you can see the median is still 30. So this is what I mean by being robust. It is not sensitive to extreme values. So when we have a skewed data like this data, right, it is positive skew, right? Most of the extreme values are to the positive side. So this is this type of data. Mode is the best thing to use because it does not have an effect on mode, right? Mode will always be mode, even if the values sway way bad, like we have extreme values in our data. So when you have a ordinal data, the best measure to use is mode or the median, right? Again, you can use mode and median for ordinal data, and we talk about ordinal data in the second tutorial of this series. And ordinal data is just categorical data that has sense of ordering. The best thing to use is to use a median and the mode for this kind of data set. So we've already looked at ordinal data set, as I said. So yeah, that's what I wanted us to cover in this tutorial. So in the next tutorial, we will start looking at estimates of variability. So this is actually an error, variability. Okay, I will change that. So in the next tutorial, this is what to be looking at. In the next tutorial, look at error estimates of variability, and then from there I'll look at the standard deviation, range, mean, absolute deviation, and stuff like that. So this is what to be looking at in the next tutorial. Again, if you find this tutorial helpful, please kindly leave this tutorial, drop a like on this tutorial, and then leave a comment in the comment section why you like this video. If you hate this video, give it a dislike, and then give it a thumbs down. Leave a comment why you hate the video, you don't like the video, and give any feedback on what I can do to improve this series, so it can be beneficial to you guys. So yeah, thanks for watching. Again, if you haven't yet subscribed to my channel, please kindly hit the subscribe button, hit the notification bell, so that you can be the first to be notified whenever I upload new videos, guys. Please kindly support my channel. This is one of the ways I can make even much better tutorials than this. So thanks for watching. See you in the next tutorial. Keep safe. We will continue with our statistics introduction to statistics for machine learning and data science series. So in this tutorial, we're going to look at estimates of variability, which is just the measure of spread. So let's just get started. So in the last tutorial, we have talked about measures of central tendency. We did mean, mode, and median, right? So this can also call the location measures, right? The location measures. In descriptive statistics, we use the location measures to measure the central tendency, right? That's what we did in the last tutorial. We looked at the mean, the mode, and the median, which are the commonly used location measures. So in this tutorial, we'll look at the second dimension, which talking about variability, which is also called the dispersion measures. Okay, whether the data values are tightly clustered or if they are spread out. That's what the variability tells us. The dispersion of data, how dispersed is the data. This is what it tells us. Okay, so variability matrices, there are a few matrices we're going to look at when we're talking about variability. So the first one is going to be range. So range is the difference between the highest value within a data set and the lowest value within a data set. So that's what range is all about. So for example, I have these values here, right? This data set. So the largest number, it's 78. They are ordered in ascending order, so not really ascending order, but you can find the largest is 78 and the lowest is 2. So the difference is 6, right? The difference is 76, which is you get it by taking 78 minus 2, which is 76. That's the range of our data. Okay, so sorry for the typo. This is actually range. It doesn't have double E. So now that you have done that, let's go ahead and see how we can do this in Python. So make sure that you activate your virtual environment, and then you open Jupyter Notebook by typing in this command. This will open Jupyter Notebook on your machine. So you can just go to that place, and then you can find it here. So you can notice I have added a new folder. This is just a folder that I added, and we'll look at it in the coming tutorial. So don't worry about it. For now, just go up here and create a new file, a new notebook, and you're going to call this simply range, because we'll be using it to calculate range. So we're going to call it a range, just like that, and you're going to save it. So let's go ahead. You're going to import few things. You're going to import Numpy for numeric Python. You're going to import it as NP. Okay, so now that you have done that, let's go ahead and create a simple data set that we can use to calculate the range. So we just go we can do data equals to np np.arrange. So we want random numbers, values between 20 and 200 with a step of 4. Okay, so the first value will be 20, the second will be 24, so like going with an interval of 4, but they'll start from 100, so they'll start from 20 to 200 with a range interval of 4 between each number. So now that you have that random data set, so that's how you can create an arrange in Numpy. Okay, so let's look ahead and get the max value of our data set. So max value value. By the way, you can't say max because max is a keyword in Python. So keywords in Python, these are words that are reserved and you're not allowed to use them as variables. Okay, so you can, one way you can escape it is by using an underscore, or just give it a more descriptive name like max value. Okay, this is what is known as a variable, right? A variable is just a container that stores data, so we can refer to it later on in our program. So that's what a variable is. So this variable is going to store something. It's going to store the data, which is this data we have created, data set we have created. There's a method called mean. Sorry, put the cursor here. So this is mean. So this will return to us the mean of this data set, and a mean in this case will be 20, right? So, sorry, the max of this. So this is actually max, my bad. This is actually max. So this return to us the max of these numbers here, this data set, the max value within. So let's also get the mean value, data dot mean, and then we can run that cell, so we can print out the max underscore value, and we have the max value, which is 196, which you can see here is 196, which is biggest value because these are ordered in ascending order. So also look at mean underscore value. This is value will be equals to, just run it, so you can see the mean value is 20, which is the first value here because it's ordered, this data set is ordered in ascending order. So we have that value, the mean here, which is 20, and then the max, which is the max value, which is 196. So to calculate range, you simply have to say range, and you can see range is a keyword in Python. You can notice the keywords, they have been highlighted in green, so we can escape that by using an underscore, and then we can say that the max is the range is, can go back the slides. The range is the difference between go back, okay, here the range is the difference between the max value and the mean value. That's what the range is all about. So let's calculate that. So we're going to say max underscore value minus the mean underscore value, and you can okay, I got an error, so this I have to use the assignment operator. So this equal sign is known as the assignment operator. So now I can go range underscore, and we can print that there. So the range of this data set is just 176, which is the difference between 196 and 20, right, which is just 176. So that's how you can calculate range of a given data set, and that's what range is all about. It's just the difference between the largest data set, the largest data in your data set, and the smallest data within your data set. Okay, the smallest value within your data set. So that's all I wanted us to discuss in this tutorial. So in the next tutorial we'll look at deviation, which is just error. So that's what we'll be looking at in the next tutorial. So guys, thanks for watching. If you like this tutorial, give it a thumbs up. If you don't like this tutorial, give it a thumbs down, and let us know in the comment why you like this tutorial or why you hate this tutorial. If there are any feedbacks on how I can improve this tutorial to benefit all of us and you guys mostly, please let me know. Leave a comment in the comment section below, and guys, help me by subscribing to this channel and liking this video. So thanks for watching. See you in the next tutorial. So in this tutorial, we're going to go over deviation. So in the last tutorial, we looked at range, right, which is the difference between the max value and the mean value of the data set. So in this tutorial, we'll look at range, deviation, and deviation is just the difference between the observed value and the estimate of location. So it's also called error or residue, right? A residual. So it's just, for example, you can calculate the deviation from the mean. So you can calculate take the value and then you minus it from the mean. So you can calculate deviation from the mean, deviation from the median, and stuff like that. So let's get started. So as usual, make sure that you have your Jupyter notebook opened and your environment is activated, and then you type in Jupyter space Jupyter space and then notebook. This will open your Jupyter notebook for you. So you can just go there and you'll look at this spot, and then you can create a new folder here. So you can create a new folder, and you're simply going to call this folder deviation, because you're going to be using it to calculate deviation. So we just call it deviation. So this is deviation, and then in here you need to import a few libraries. So you're going to import Numpy again, so numeric Python. We're going to import it as a np, and then we can run that. So let's go ahead and create a simple data set. So we just call it data, give it a variable, we call it data. And in this variable, we're going to store an arrange. We're going to create an array, a numpy array, using the arrange method. So you can give it from numbers between from 20 to 200 with steps of 4. Okay, so we can print out data, and then we can have those number right here. So we can check the length of that data by using length, and then we have the length of the data. So the length of the data is a 45, mean that there are 45 numbers in here. So let's go and actually calculate the mean of this number. So you can to calculate the mean, you can just go data dot mean, and then we can store this in here. You can go, let's use this way, numpy dot mean, and then this way, and then in here you need to pass in the data. Want to calculate the mean of that data, and then you can call it a mean, and then we can store it in there. Then you can simply print mean, and you have the mean to be 108. So now that we have the mean, let's go ahead and see how we can actually calculate the deviation. So the deviation from the mean, which is just the each value minus the minus it from the mean of that whole data set, so of that sample data set or the population data set. So to calculate, we just call it deviation, and this will just be equals to the data minus the mean. So this is where one of the powers of numpy comes in play. So what this is going to do, an element wise operation. So it's going to take each element in here and minus the mean from it, right? So it's going to take 20 minus 108, 24 minus 108. We don't have to write any complicated loops or stuff like that. If you know what a loop is, it's fine. I'll probably look at loops in the future. So that's one of the main powers of numpy. If you are new to programming, you might not really understand this, but if you know programming, you might really you'll start really appreciating numpy at this point. So we can go ahead and actually do the deviation, and then we can run that. You can see this is all the deviation. So 20 minus this, you get this, which is minus 88, and you can see all that deviation right there. So that's how we can calculate deviation, and you can also find the sum of this. So you can go numpy dot sum, and you can pass in deviation, so you can get the deviation. So you can run that. You can see we got 0. So the deviation of this data set actually equals back to 0. Okay, so that's all about deviation and how we can calculate deviation using numpy. Okay, so thank you guys for watching. If you like this tutorial, again please subscribe to my channel. If you like this video, give it a thumbs up. If you hate the video, give it a thumbs down, and let us know in the comment section what you like about the video or what you dislike about the video. Leave feedbacks on how I can improve this set of series, so that you guys can benefit mostly from this set of tutorials. Again, if you are new to my channel, please kindly hit the subscribe button. This channel is all about data science and machine learning, Python, and programming stuff in general. So please give this video a thumbs up and hit the subscribe button, hit the notification bell, so that you can be the first to be updated and to get the notification when I upload the next tutorial. So the next tutorial will look at variance and standard deviation in using pandas or numpy. Okay, so thanks guys for watching. Please see you in the next tutorial. Don't forget to like this video and subscribe to this channel. We're going to look at variance. So in the last tutorial we looked at deviation. So in this tutorial we're going to look at variance. So variance is also called the mean squared deviation or the mean squared error. So this is how spread out our data is. So that's what variance tells us, how dispersed our data is from the mean, from the central point. How far is our data spread out from the central point, which is mean. Okay, that's what variance tells us. So variance is also called the mean squared deviation. So in the last tutorial we looked at deviation, and you might notice this is the formula for deviation, right? The value minus the mean of the whole data set. So the mean, which is the average, squared deviation. So the deviation is squared, and then we find the mean of that deviation. Again, there is a this is a fraction. There is a line here, but this editor doesn't show it. Let me just exit slide mode, and you can see that's the formula right here. So that line is over there. Okay, so now let's go back to presentation mode. Okay, so this is the formula to calculate variance. Okay, so there are two formulas. So there is the first one which with the denominator is just n minus 1, and there is a second one where everything else is the same, but the denominator is n only, not n minus 1. So this is a debate in statistics to which is the best, because both of them are used and are acceptable. This leads to something known as the degree of freedom, whether you can do n minus 1 or you can do n as a denominator. So what most books suggest, some of the books say that the most intuitive formula, the way of the denominator being n, right, which is how you find mean, right, average. this actually underestimates the variance, and you will see this just in a short while. So however, even using the n will be unbiased. Okay, so when I use the n minus 1, our variance will become unbiased, but if you use just the n, the variance will be underestimated. So now let's go ahead and actually see how we can calculate that. So let me just close this up, and then here we can make a new Jupyter notebook, and you're going to call it variance underscore deviation. Standard deviation. So we call variance underscore we're going to call it standard deviation, std, and then that's okay. So we need to import a few things. We're going to import Numpy and Numeric Python. So import Numpy as np, and then we can run that cell. So to run the cell, just press shift and enter on your keyboard, or you can just select the cell by tapping on the cell and then pressing the run button. Okay, so now let's create a variable, call it data, and you're going to create an arrange of data. So we're going to call np, we're going to call it np.arrange. Okay, so we're going to create from 20 to let's say 300. 4,000 is 3,000 is too much. And then we can go ahead and actually look at the data, and then we can look at the length of that data, which is about 70 elements. Okay, so now let's try to see how we can calculate the variance of that data. So you can see np.var, which is just stands for variance, short for variance, and in here we can pass in our data. So you can press that, and then we can see we have, this is the variance of this data set. So this is the variance of our data. So now that we have the variance, let's try to so this tells us how spread out the data is. So let's do something. Let's change from 4 to okay, let me tell you what 4 does. So whenever we put in here 4, the difference between the interval between every element within our data will be 4. So you can see 20 and then 24, 28, like that. So interval is 4. So that's how spread out the data is, by 4 elements each. So let's see how we can change this to 10. So the difference will be the steps will be 10. We have 28, and then we can see now the variance has dropped. Okay, so now if you didn't notice that, let me just bring this back to 4, and then I can run this. So let me store this in a certain variable. Call this one let me call it before variance, and then I'll run the cell. Well, this is let me just come up here, run everything again, and then we can print before, and then we can see this is a variance. So now let's change this back to 10. This will be 10, and then we run this. So we have 28 elements. We will not run this cell. We can run this cell, and then down here don't run this cell. Okay, this one 14, do not run it because it will change that value. So now let's do again after, and then you're going to store in here np.var, and then we're going to pass in data. And then you can see the you can print out after just like that, and you can see the variance before doing the spread. The variance was 130, 120, 132, and then now it is it is 6,532, and now it is 6,525. So you can see now the data is much less spread. So let's try to change this back to 5, and then let's see what we have. So you can see that the data, how spread out the data becomes whenever I use 5, it becomes this one. Okay, so that's how we can calculate the variance. So now let's look at standard deviation. So we have talked about the degrees of freedom, so let's see how we can implement the degrees of freedom in here. So I'll just make this to be this one, and then I'll simply remove the cell out, and remove this cell as well. So also remove this cell. So now we can go ahead and actually see, we can press shift and tab. Okay, put your cursor between the parentheses and then press shift and tab. Parentheses are these curly braces, so put your cursor in there, then press shift and tap on your keyboard. This will bring for you this little documentation. Press on the add button, and then you scroll down, you can see what you're supposed to pass in. So A will be the data, and then axis, we will not talk about axis for now, and then what you're interested in is the DDOF. Okay, so the DDOF by default is 0, so you can see by default is 0. So let me just take you to the Numpy official documentation. So this is the numpy.var, the official documentation. So this is what they said. they call it delta degree of freedom, DDOF, delta degree of freedom. So the divisor used in the calculation is n minus dd of freedom. So if you specify dd of freedom to be 1, then this will be this formula will be used. So by default, Numpy uses this one where the DDOF is 0, the delta degree of freedom is 0. But if you can use this one by specifying 1, by making the delta degree of freedom to become 1 as they specified here. So whenever you pass in 1, what to n is the number of elements, so we just take the number of elements minus 1, which become which will be exactly this formula right here. So you can go ahead and actually specify that. So you can just come in here and then say DDOF, DDOF, and then you can specify this to become 1. So whenever we run this, and then we can do before, and then we can run that cell, so you can see the degree of freedom becomes this one. So let me just create another cell up here, and then I can do mp.var, and then we just pass in the data without the degree of freedom. So you can see there is a slight difference between the two. So this underestimated the variance, right? Underestimated it, as we said over here. So you can see it underestimated it using the of n, which is by default this one, without specifying the DDOF to be 1. We'll be using the denominator to be n, and if you use the denominator to be n, our value gets underestimated and we have this value. But if you use the DDOF to be 1, then our variance becomes unbiased, right? Becomes unbiased, and you see this one, using this will be the unbiased estimate. So this is the unbiased estimate. So just know what you want. Some books argue that the difference is not that much, but just know what you want to do, and then you can choose which one to use. So that's how you can specify the DDOF, the delta degree of freedom. Also in statistics, it's called the degree of freedom. Okay. So yeah, that's all I wanted us to talk about in this tutorial. So in the next tutorial, we're going to look at percentiles, right? So we're going to talk about percentiles and what they are. So if you like these tutorials, give it a thumbs up. If you hate it, give it a thumbs down, and let us know in the comment section what you like about this tutorial or what you hate about this tutorial. Also drop a feedback so that I can know what I'm doing wrong and what I'm doing right, so that I can improve on this set of tutorials. So guys, thanks for watching. Again, if you have not yet subscribed to my channel, kindly hit the subscribe button and hit the notification bell for more videos like this. Thanks for watching. I'll see you in the next tutorial. Keep safe. This tutorial we're going to continue with the machine learning introduction to machine statistics for machine learning and data science series. So in the last tutorial we looked at the variance. So in this tutorial we look at deviation, standard deviation. So standard deviation is just the square root of variance. That's all it is. Okay, so in the last tutorial we looked at the variance, which is just sigma squared, right? So standard deviation is just the symbol for it is just sigma equals to, and then this under square of the variance formula. Okay, this is a fraction, so let me just exit presentation mode so that you guys can see that. So this is actually a fraction. I don't know why when I go into presentation mode it doesn't display the line. Okay, so now that's the formula to calculate standard deviation. Okay, so what we just take this the formula for variance, which we covered in the last tutorial, right? So the formula for variance, this one, we simply put it under square root. We also make this under square root, so this becomes just sigma itself, not sigma squared. Okay, so now that's the symbol for standard deviation, and the formula for it is just the square root of variance. Okay, so in the last tutorial we looked at variance this way, right? So we calculated this. So now let's try to look at the square root of variance. So you can just say np numpy.sqrt, which stands for square root, and we're going to pass in before which is the data that the data in which we stored the variance. Okay, so you can run this and you can see the standard deviation, which is the square root of this value. So now what if you want to calculate the standard deviation directly? Numpy has a formula for that. So you can do std, and then you pass in data, and then I think in here you can also pass the degree of freedom if you want. Yeah, so let's pass in the degree of freedom, delta degree of freedom. So this will just be 1, and then we can run that. So you can see we have that number right there, which is the same as this. So that's how you can calculate a variance standard deviation in Numpy. Okay, that's how you can calculate standard deviation from the square root of variance. So that's all. So the reason why you would want to use variance other than the reason why you want to use standard deviation rather rather than variance is that variance, the unit of the, for example, let's imagine that this unit is meters, right? All of these units here, they are all of this data, they have a unit of meters. So if you use the standard deviation, the variance, then that meters will be squared, right? Because standard variance, the answer becomes squared. So it doesn't, but it's really difficult to interpret the square because what you are working with is meters, right? Not meters squared. So what you want to do is to bring this back into meters so that you can really compare it with the original data set and try to make inferences that way. So this is one of the powerful advantages of using a standard deviation instead of using the variance. So if you find the square root of it, you get the value, the unit of the data set instead of the square of the unit of the data set, which makes it easier to interpret your data, right? For example, if you calculate the variance of heights of people, you get maybe like a feet squared. So if you find the standard deviation, you get feet, which is the normal standard unit of comparison between heights, right? So that's the powers of using a standard deviation. So yeah. Also, we can also look at the absolute deviation, which we'll look at in the next tutorial. So this is all I wanted us to discuss about, and now you know what standard deviation is and why you would use it over variance. And you also know that standard deviation is just the square root of variance. Okay, so guys, thanks for watching. If you like this tutorial, again, give it a thumbs up. If you hate it, give it a thumbs down. Leave a feedback in the comment on how I can improve on this set of tutorials. Again, if you haven't yet subscribed to my channel, I kindly ask you to hit the subscribe button, hit the notification bell so that you can stay updated every time I upload a new video. So thanks for watching. Again, please subscribe to my channel, like this video, and leave a comment in the comment section below on any feedback that you have. So thanks for watching. I'll see you in the next tutorial where I'll go over the mean absolute deviation. So thanks for watching. In this tutorial, we're going to look at the mean absolute deviation. So the mean absolute deviation is the mean of the absolute values of the deviation from the mean. It's a bit confusing, but it's also called Manhattan norm. Okay, so it's also called the mean absolute deviation. Well, this is the formula for the mean absolute deviation. So what the difference is between this and the variance is that this one is we take the absolute value of it. Also, it is also a measure of dispersion of data, how far the data is from the central value, okay, on average. So this is how you can calculate it. So let's go ahead. This is how the formula is, and again there is a line here. So let me just exit presentation mode. As you can see that we have a line right there. So this is actually fraction. So I don't know why it doesn't display when I go into presentation mode. I probably have to fix this sometime. So now let's just make sure that you have your Jupyter notebook opened, and then you simply create in here a new file, and then you're going to call it let's just load up. You're going to call it mean absolute deviation. Just let's call it mean absolute deviation, just like that. And we're going to import a couple of things. So the first thing we're going to import pandas, so pandas as a PD, as we usually do, and then we run that cell. So let's go ahead and actually create a data frame. So a data frame, we talked about the data frame in the very first second tutorial. We talked about the data frame being just a rectangular data in pandas, in data science. So let's go to say pd.data. Watch out for the capital the casing, right? So it's a case sensitive. Python is a case sensitive language, meaning that a small letter d is not the same as a capital letter D. So watch for that. This is capital D and capital F in data frame. So now that you have created that data frame, you can run it, and then we can go df. Then we can say, we can assign here, we're going to create a variable, and you're going to call it a variable or a feature. We're going to call it data, and you're going to give it a set of data. So let's go ahead and actually create that data. So first of all, we need to import numpy. So import numpy as a np, just like that. And then sorry, I got a value, so an error. So up here we're going to create that data frame. So we're going to call it data, and then you're going to say np.arrange. By now we are probably used to this, so we're going to go from 20 to 400 steps of let's say steps of 5, or let's say steps of 20 is fine. And then we can go ahead and actually print that data, and then we have that data there. So we're going to assign this to be the data. So this column within our data frame is going to have these values, right, for each row. each row have its one element from here. So we can run that, and then we can go a df, and then we can see we have that data frame right here. We have all the columns being like that. So now that we have that, let's go ahead and actually calculate the mean of that. So you can just go data. Again, if you are new to Pandas, you want to understand how Pandas work, I have a whole series on Pandas on my YouTube channel. You can click that and watch the whole series on Pandas. So let's go ahead and actually create that here, down here. So we're going to say data I call it df, and then you're going to access the data column. You're simply going to say .mad. So MAD stands for mean absolute deviation. So we run that. So the mean absolute deviation of our data is 94.736 and so on. So that is approximately 94.737. That's approximately rounding off to 3 decimal places. So 4 decimal places, right? 3 decimal places rather. So that's how we can calculate the mean absolute deviation in using Python. So one thing that people argue is that the mean absolute deviation is obsolete and is not commonly used. So what is commonly used is the median absolute deviation. So the deviation from the median of the data set. So to calculate the median absolute deviation, let's come up here, and then we're going to import let's say from scipy. So scipy is one library that we installed. We're going to import stats just like this, and then we come down here. We're going to just pass in here. We're going to say stats dot median absolute deviation. It is an underscore, absolute deviation, and then you're going to pass in here our data, and we can run that. So we have the answer here. So our median absolute deviation is 148.26. Again, what this error tells us that this is depreciated, so we need to use this. So we just need to say APS, and then that error is gone. Why did the value change? Let's see why we got that error. So absolute, let's run that, and let's see what this depreciation warning. The is depreciated, use this one instead. So let's say they told us to use this one instead. So they probably made some changes. So now this is, maybe they fixed some error. So that's this is now the median absolute deviation. Maybe they had some errors in their code, that's why they want us to use this one. So that's how you can calculate the median absolute deviation in Python using scipy. So that is this all I wanted us to discuss in this tutorial. So in the next tutorial, we'll probably go over we'll start looking at percentiles in the next tutorial. Okay, so guys, thanks for watching, and if you have not yet subscribed to my channel, please kindly subscribe to this channel, give this video a thumbs up. If you don't like the video, give it a thumbs down, and let us know in the comment section what your opinions are about this series, and any feedback on how I can improve this series, please let me know. If you have not yet subscribed to my channel, please kindly hit the subscribe button and hit the notification bell, so that you'll be the next one to be you'll be the first one to be notified when I upload the video on percentile. So thanks for watching, guys. Keep safe. Thanks for watching. Like this video. In today's tutorial, we're going to go over what are percentiles in statistics and how they can be applied to machine learning and data science. So given a data set, the pth percentile is the value such that p percent of the data takes on this value or less than it, and 100 minus p, which is finding the other percentage of the value, takes on this value or more. Okay, so that's what percentile is all about. So if, for example, if I say my 50th percentile is 25, meaning that 50% of the data is above 20, is below 25, and 50% is the other 50% is above 25. That's what it means by percentile. Okay, so let's look at what are quantiles. So quantiles are essentially the same as percentiles, but they're expressed in form of decimals. Okay, this I didn't actually expressed in decimals, while the percentiles are expressed in scale from 1 to 0. So you just write for percentile, you write it as a normal percentage, while for quantiles you write this as a decimal representation of that percentage. So for example, the 50th percentile is the same as the 0.5 quartile. Okay, it's the same stuff. So also note that the 50th percentile is the middle value of the data set, so it's the median, right? We have talked about median being the middle value of a given data set, so that's what also quartile, the 50th percentile, the 0.5 quartile is about. So let's look at the difference between this. So quartile means the difference between quartile and quantile. So you can see they are very similar words. So I got this from differencesense.com, so you can just go to I'll leave this link, I'll try to leave the link in the description. You can find this video on this explanation from differencesense.com. It's just a great website, so just go there and check out their video. It's really just awesome. So now that you have done that, let's the difference between quartile and quantile. Okay, so quantile means one of the classes of values of a variable which divides the members of a batch or sample into equal size subgroups of adjacent values, or probability distribution into distribution of equal probability. So I'm just paraphrasing what this guy said. The explanation is really just awesome. So whereas a quartile means any of the 3 points that devise an ordered distribution into 4 parts, each containing a quartile of the population. So what does it tell us? That before you can begin to find percentile or quartile, you first need to order your data into a certain order, right? You have to have an ordering, right? You have to do order statistics. So that's all there is. So there's a difference between percentile and quartile. So you can think of quartile like quarters, right? So it divides something into different quarters. So there's also something known as deciles. There is I think it's called, I really can't pronounce that word, so I'll just leave a link where you can read more about it. So that is it. So the first quartile is known as the 25th percentile or 0.5 quantile. So this is the second quartile is the 50th percentile, and then the third quartile is the 75th percentile. Okay, so think of quarter like a quarter, as I said earlier on. So we'll be looking at the interquartile range. So the first quartile is the 25th percentile, the second quartile is the 50th percentile, and then the third quartile is the 75th percentile of a data set. So let's go ahead and see how we can calculate this. So just go ahead and create a new notebook, Python notebook. So let's wait for this to load. You can just call it percentile. Okay, so let's save this as percentiles. Okay, save this as percentile. So before to calculate the percentiles, we're going to use in here we're going to use a data set. So we're going to use a data set of the heights of people and the weights of people. So you can find this data set at kaggle.com. so I'll leave the link in the description where you can download this data set. So whenever you go to click on the link, you bring it to this website. You simply have to click download. So it will download a zip file in your for you in your downloads folder. Extract that zip file, and then you get a file of weights, which will be, let me just show it to you. So it will be a size of weight. So this one, this will be the name of the file. So after you do that, go to your statistics folder, which is the folder in which we have all our statistics files and our notebooks. So create in here a folder called data, and inside of the data copy and paste in that weights.csv file. So a CSV file stands for comma separated values, which is just a very handy kind of files to work with within Pandas. So in data science, most of the times we'll be working with CSV files. So let's go ahead and actually load in that CSV file. We're going to load in the CSV files into a data frame, which is just a rectangular data using Pandas. Okay, so I've already created a notebook. So I'm going to import Pandas. So I'm going to import let me make that, get the spelling right. So import Pandas as PD. So I run that cell. So I'm going to create a data frame, which is just be called df, which is variable, and I'm going to say PD, which is the alias name, dot read underscore CSV. So we're going to read a CSV file. This is just a method that will allow us to read a CSV file. So in here, I need to provide a string, and in Python, a string is anything that is between single quotes or double quotes. Okay, so we're going to just type in, as I say, dot backslash / data. If you're on Windows, I think it's backslash and then another slash, and then you need to specify the name of this file, the weights file. So just go in here and then you can copy this name. Let's get the name right, copy that. So make an error, so make sure I copy that. It's just difficult to copy this sometimes, so we just copy this and then we move back in here to our file and then we paste in that there. So make sure I fix that. So you're simply going to import in that file, or you can just, if you you can just specify the directory in which you store that file if you're familiar with specifying paths. So you can do a df, then we can see we have loaded in that CSV file. So the CSV file, if you go to the cargo.com, it does that it has the following column. So it has column for these columns, right? The height, the weight, and then the gender. So we go back here and then we can see we have exactly that in here. We have the gender of the people, their height, and then their weight. Okay, so now that you have loaded that into a CSV file, let me just show you some things that you can do with a data frame in Pandas. So you can go ahead and actually look at the shape of the data frame. The shape, it tells how many columns and how many rows are there. So the first value will be the number of columns, and then the second will be the number of rows. So this is called when we have a data set like this, where you have a parenthesis and then the values are inside of that parenthesis, it's separated by a comma, it's known as a tuple. Okay, that's a tuple in Python. So this shape returns to a tuple where the first element, which is this 10,000, is the number of rows. So we have 10,000 rows in our data set. In here you can see we have it ends at 99 because we start from 0. That's why it ends at 99. So if you start from 1, you get 10,000. I mean 9,999. Okay, then we have 3 columns, which is the gender column, the weights column, and then the heights column. So we can also look at the info and stuff like that. So you can do a df.describe. So describe, this will just give you a brief description of your data set. So we have a brief description. So you can see we have on average our height is about 6.6, and then on the standard deviation is a 3.8. The mean is this much, and then the quartiles are this one. So these are the percentiles, right? So let's see how we can calculate these percentiles ourselves. So this is the 25th percentile, the 25th percentile, which is the first quartile. This is the second quartile, the 50th percentile, and then 75th percent, which is the 25th the 75th percentile. Okay, so let's see how we can calculate this on our own. So we just have to call it data. I call it df, so data frame, so short for df. So to access a column, you can just use the data frame or whatever you called this right here, whatever you used here. You specify it here, and then square brackets, no spacing, right? So the name and then the square brackets, and then in here you're providing a string, and you say that a string is anything that between single quotes or double quotes in Python. And then this in here you want to specify which column you want to access. I want to access the height column, so I'll just copy this and I'll paste it in here. So I'm going to access the heights column. So if I run this, I'll just get the heights back. So I'll just get the column for all the heights in our data set. Okay, if you want to go for weights, I'll just copy weights and paste in here. This will just get returned to this variable. Okay, just this column. Or another way you can go around it is just by using dot and then the name of that column that you want to access, and then you get back the same data. But in common best practice, I just use this. Okay, this is what is commonly used. So let me just undo, and then I run that again. So now we have that there. Let's go ahead and actually try to see how we can calculate the percentiles and the quartiles of this. So first, let's begin by importing you can go ahead and okay, let's just go ahead and calculate it here. So just copy this, I'll copy this, and then I'll bring it here. So I'll bring it here, and then I can do dot quartile. Okay, it's called quantile, not quartile. So quantile, and then in here I can provide in a decimal. We say that quantile, the difference is that quantile takes in a decimal, while percentile takes in a range between the scale of 1 to 100, right? So in here I'm going to provide 0.25, right, which is the 25th percentile, which is the same as the first quartile. So I'll run this. Let me store it in here. Let me call it Q1, which is the first quartile, and then I run that, and then I can print here Q1, and then you can see we have the first quartile as being 63.556, right? So 63.506. Okay, so what this tells us that 25% of all heights are below 6.3 feet. So this is inches. So if you convert it to feet, it's about like 3.35056 feet. Okay, so that tells us that most 25% of people are below this height. Okay, now let's look at the according to the data set, right? So according to the data set, so let's change this to 2. I look at the second quarter, which is just 58. So you can see, and then we can print that out, and then we can see that 50% of people are below 6.63118 feet. Okay, so that's what it tells us. That is the 50th percentile, or 0.5 quantile. Okay, so now let's look at the third one. So just paste what I've already copied earlier. So this will be the third quartile. It will be Q3, and this will be the 75th percentile. So I change this to be 75. This will be 75, and then I can run this, and I can print out Q3, and then we have it there. So 75% of people are below 6.9174 feet, right? I mean, yeah, feet. And again, this shows that 25% of the population is above this value. Okay, so there are some really tall people out there. So we can see that value over there. So we can also calculate the mean on average, what is the height of the people and stuff like that. So that is how we can use quartile. What if you want to use percentile? Because the only difference is that percentile uses range numbers between 1 to 100, right? So let's go import Numpy as np, and then we can run that cell again. Make sure you run that cell, or else you get an error. So go to np.percentile, and then in here you can provide in a data frame, which will just be df, and then we need to specify that you want the height column, and then yeah, you can specify here q. I think, let me just look at the documentation. Just press shift and enter. Yeah, you're going to provide in here q. So you need to provide in q, which is the percentile that you want. So let's say I want the 25th percentile, and that gives me 6, which is the same as the first here, which when you use quartile. So that's the only difference between percentile and quartile. This one uses fractions, decimals, and this one uses whole numbers. That's the only difference. So now that you have looked at that, let's go ahead and actually have some fun and try to calculate get some insights. Let's try to look at the variance of the human height, right? So how spread it is from the mean, right? How dispersed is human height. So we copy this and I'll paste it in here. So we run that. So on average, the spread is about 14, right? 14.08. So that's how far on average the height is from the mean. So let's try to calculate the mean. So you can just go df, and then we can do height, and then in here we can do dot mean. This should return to us the mean. So on average, people are about 6.6 feet, right? So that's on average according to that data set. Okay, this may not be the real case, but according to that data set, and it's actually a lot, right? 10,000 people. So we can draw a conclusion from that. So that's how we can do that. So yeah, that's how we can do that there. So you can also go ahead and actually calculate according to gender and stuff like that. So if you want to do according to gender, I'll just teach you the way. So I'll just go df underscore male, how to select height of only male. So just go df, and then you need to say df, and then in here you specify gender, which is the column for gender, and then you have to say that gender is equals to male. So these values I'm getting is from the data frame, right? We have the gender column. I want to select the gender column where it is male, so male is capital M. So that's where I got that data from. That's how I typed in that. So if I look at df underscore male, so this will just return to me all only males and none of female. Okay, so that's how you can calculate. So my assignment to use that, calculate the variance for mean, calculate the variance for the male, and then you can calculate the variance for the male and then the female gender, and then you can also calculate their standard deviations and stuff like that. So you can do np.std, and then you can pass in df, you can pass in height, just like that, and you can see the standard deviation is this much, okay, on the spread. So yeah, that's all you can calculate. Also in here I said that it's spread about 14.9. I was actually wrong because this is squared, right? So feet squared. So you have to find the standard deviation in order to make that conclusion. So on average, the spread from the mean is about 3.847. So I was really wrong here. I mean, how can the height be like 14, right? 14 feet. Just maybe it's not possible, right? Okay, so that's how you need to first find the standard deviation in order to draw that conclusion. So on average, people are spread away from about 4 feet from the average normal human height, which is about which you got to be 6.6 about 6.6 feet. So that's all I wanted to discuss in this tutorial. So in the next tutorial, look at something known as the interquartile range and how we can see that, how we can use that to clean our data. So guys, thanks for watching. If you enjoy these tutorials, please give this video a thumbs up. If you hate it, let us know why you hate the video, give it a thumbs down, and then if you haven't just subscribed to my channel, please kindly do so. Thanks for watching. I'll see you in the next tutorial. Keep safe. Hello YouTube, welcome back to my channel. So in the last tutorial we looked at what percentiles are and what quartiles are. So in this tutorial we're going to continue with building on that knowledge. We're going to look at interquartile range, right? So in the last tutorial we talked about quartiles and what they are, like the 25th quartile and the stuff like that. So let's revise on that. So we have the first quartile, which is the 25th percentile, the second quartile, which is the 50th percentile, and then the third quartile, which is the 75th percentile. Okay, so the interquartile range is just the IQR, which is commonly used for equals to the third quartile minus the first quartile. So the difference between the 25th percentile and the 75th percentile is what is called the interquartile range. Okay, so now let's move back to this tutorial. So in the last tutorial we're able to calculate these values, right? So we're able to calculate the third quartile and stuff, the first quartile, the second quartile, and then the third quartile. So make sure you run this notebook again, or else you might get error. So make sure you run all the notebooks again. So just go up here and then click run all. This will run the notebook for you. So now you can see we have calculated the 25th percentile, which is the first quartile in the last tutorial, right? And we called it, we assign it to a variable called Q1, and then we also have Q3, which is the 75th percentile. So now let's calculate the interquartile range. So I'll just go IQR, which is the difference between we take Q3, right, which is the third quartile, minus the first quartile, which is Q1, and then we can run that. So we can just go ahead and print here into quartile range, and then we can run that. So it is the interquartile range of our data, which is about 5.66864. So this is very important. Right now you might not really see the power of interquartile range, but in the future we'll use the interquartile range to clean our data. So this is very powerful to detect outliers, and I didn't want us to go into that right now. I think it's earlier on in the series, so we need to look at first distributions first and how to explore the data, and then from there we'll be able to do data cleaning using the interquartile range. So this knowledge will become very handy whenever we talk we are going to go into the section of cleaning data using different statistical methods. So again, there are other things that I want you to go and read. So just go to DevSense. I'll leave the link in the description. Just go to DevSense, and then you can watch this read this documentation. It just has a lot of information there. So yeah, it's just an amazing website. So just go there and read about it. So we have talked about the interquartile range and where do we apply it in data science and machine learning. We apply it in fields like cleaning data and detecting outliers. So it can be used to detect outliers and how to clean the data using the interquartile range. That we'll look at in the future coming series. So as I said, you can detecting outliers using the interquartile range, and then in the next tutorial we'll look at exploring data and distributions. From there, that's when we start looking at how to clean our data using the knowledge of the interquartile range. So that's all I wanted us to talk about in this tutorial. If you find it helpful, please give this video a thumbs up, and if you don't like it, give it a video a thumbs down, and let us know in the description why you hate the video or why you like the video. So thanks for watching. See you in the next tutorial. Keep safe. If you have not yet subscribed to my channel, please hit the subscribe button and hit the notification bell so that you can be the next the first person to be notified whenever I upload the video and exploring data and distribution. So thanks for watching. See you in the next tutorial.